Hello everyone, welcome back. Today we're setting our sights on the captivating world of gyroscopes and spinning tops. These spinning marvels have left many scratching their heads, wondering about the science that makes them work. What makes a gyroscope maintain its orientation? Why does a spinning top eventually topple over? These questions and more await us as we delve into the physics of rotation and angular momentum. So, fasten your seatbelts and prepare to be intrigued. Stay tuned as we unravel the mystery behind these fascinating objects. A gyroscope is a device used for measuring or maintaining orientation and angular velocity. At its core, it's a spinning object that manages to maintain its orientation, no matter how you move the platform it's on. This unique ability is what makes gyroscopes so useful in a variety of applications. For instance, let's consider navigation systems. They heavily rely on gyroscopes to provide accurate information about direction and orientation. In the area of aerospace technology, gyroscopes play a crucial role in helping spacecraft maintain their course in the vast expanse of space. Even in the palm of your hand, within your smartphone, a tiny gyroscope is hard at work, enabling features like screen rotation and augmented reality. Similarly, drones use gyroscopes to stabilize their flight and capture smooth footage. Now that we know what a gyroscope is, let's move on to understand how it works. A gyroscope works on a principle called gyroscopic precession. Picture a bicycle wheel. When it's spinning fast, it doesn't fall over, right? That's because the spinning wheel acts like a gyroscope. The wheel's resistance to a change in its orientation is what we call gyroscopic precession, and it's the secret sauce behind how gyroscopes work. Now, let's peel back the layers a bit. The gyroscope's ability to maintain its orientation, even when an external force is applied, is due to a fundamental physics concept known as angular momentum. Think of angular momentum as the quantity of rotation an object has. The more angular momentum a spinning object has, the harder it is to stop it from spinning. This is why a gyroscope, once set in motion, tends to stay spinning. But what happens when we apply an external force to our spinning gyroscope? Well, instead of coming to a halt or changing its spin direction, the gyroscope exhibits a curious behavior. It starts to pivot around an axis perpendicular to the force applied. This phenomenon is what we call precession. To better visualize this, consider a spinning gyroscope mounted on a stand. If you try to tilt the stand, the gyroscope doesn't just fall over. Instead, it starts to process or pivot around in a direction that's at a right angle to the force you applied. It might seem like the gyroscope is defying gravity, but it's just physics at play. And the final piece of the puzzle is torque. Torque is a measure of the force that can cause an object to rotate about an axis. In our gyroscope, the applied external force generates a torque that causes the gyroscope to precess. So, to sum it all up, a gyroscope works on the principles of angular momentum and precession. The spinning object resists changes to its orientation due to its high angular momentum, and any external force results in a gyroscopic precession rather than a change in the direction of spin. Now that we understand how gyroscopes work, let's look at spinning tops. A spinning top, like a gyroscope, is an object that spins around an axis. However, while they share this similar feature, the way they interact with their environment is where they truly differ. A spinning top is a toy that spins around a fixed axis. It's set into motion by a quick twist of the fingers, and then it dances around, seemingly defying gravity. But unlike a gyroscope that maintains its orientation in space, a spinning top rotates around its axis due to angular momentum. This is what gives it that mesmerizing twirl we all know and love. However, there's a catch. The spinning top is not immune to external forces. In fact, it's quite susceptible to them. Friction from the surface it's spinning on, and gravity pulling it downwards play a significant role in its performance. These forces cause the spinning top to wobble and eventually lose its balance, leading it to topple over. This is a stark contrast to the gyroscopic precession of a gyroscope, which resists changes to its orientation. In essence, while both spinning tops and gyroscopes celebrate the wonders of rotational motion, they do so in different ways. A gyroscope's ability to maintain its orientation in space sets it apart from the playful yet transient dance of a spinning top. Now let's dive deeper into the physics behind these fascinating objects. Gyroscopes and spinning tops operate on the principles of angular momentum, torque, and rotational motion. While they may seem like simple playthings, these objects are masterful demonstrations of some of the most fundamental laws of physics. Let's start with angular momentum. This term might sound complex, but it's simply the rotational equivalent of linear momentum. In essence, it's the quantity of rotation an object has. Both gyroscopes and spinning tops maintain their spin due to the conservation of angular momentum. This principle states that unless acted upon by an external force, the total angular momentum of a system remains constant. Now, on to torque. Torque is a measure of how much a force acting on an object causes that object to rotate. When a gyroscope or a spinning top is set in motion, there's a torque applied. In a gyroscope, the torque caused by gravity pulling down on the device's center of mass results in a motion called precession. For a spinning top, the torque due to gravity causes the top to wobble in a circular path around the vertical axis, a phenomenon known as nutation. Lastly, we have rotational motion. This is the movement of an object in a circular path around a central point. Both gyroscopes and spinning tops exhibit this kind of motion, but they respond differently to external forces due to their unique designs and functions. When a gyroscope experiences an external force, it responds by moving in a direction perpendicular to that force, a behavior known as gyroscopic precession. On the other hand, when a spinning top encounters an external force like friction or gravity, it gradually loses its balance and topples over, ending its beautiful dance. These principles of physics aren't just confined to the realm of toys. They're at work in a multitude of applications, from the navigation systems of submarines and spacecraft, to the stabilization mechanisms in your smartphone camera. That concludes our journey into the world of gyroscopes and spinning tops. Remember, the next time you see a gyroscope or a spinning top, there's a whole lot of science spinning along.